This is 3.3 part 3. And the first thing we're asked to do is factor 4x squared plus 6x using algebra tiles. And sometimes it's actually easier just to use the actual algebra tiles because you see how they fit together properly. So what we're asked to factor is 4x squared plus 6x. So I'm actually going to use these. And I'll just move this to the side for a second. We need to have 4x squared. So 4x squared meaning 4 of these. And the red side's negative, so I'm going to put the red side down for these particular tiles. And we have 6 x's. 1, 2, 3, 4, 5, 6. And we have to form a rectangle. I've already put these in a square shape, so I'm going to just leave that like that for now. Now, how can I do this so it works? Well, imagine that I started out putting 4 of these here and 2 down here. Can't seem to zoom out quite enough, but you'll notice it's not quite a rectangle because I kind of have this little piece down here that's broken out. So if I move these over here and I tighten everything up, and I don't do that because that doesn't help, then I have a nice rectangle using algebra tiles. So sometimes on the side it's easier to do that first of all to make sure that you're doing it correctly. But when it says factor this using algebra tiles, then it actually wants you to find the rectangle and to draw it. So imagine those are my 4x squareds. Didn't do a fantastic job of drawing them. And then 1, 2, 3, 4, 5, 6. That's awful, but you'll have to forgive me. The actual factors are found by finding the length and width. So again, imagine you're standing here and you're going to walk from here all the way to there. So how far do you walk when you walk from here to here? Well, you've walked an x and another x. So from here to here, you actually walked 2x. Now go up here and walk this entire distance. So from here to here, you walk an x and then another x. So you're at 2x. And then you walk this little tiny distance, which is a 1, plus another 1 is 2, plus another 1 is 3. So you walk 2x plus 3. The factors are always length times width. So what is length times width? And again, we're going to put the monomial first. The monomial is 2x. The binomial is 2x plus 3. Now this next one says factor 3x squared plus 6x minus 12 using algebra tiles. And again, in order to do this properly, you're going to see you're going to have to get things to fit really well. And using algebra tiles, if you were to play with these for a bit, it's not going to necessarily work. So I will tell you when you actually have to form the rectangle and when you don't. And if you look back at your previous step, usually you will form the rectangle when you have an x squared and an x term or an x and a constant. If you have a trinomial, you're going to end up using this step here. So a trinomial meaning 1, 2, 3 terms. You're going to use these steps here. So step number 1, find or draw all the correct tiles needed to represent the polynomial. So I would have 3x squareds, 6x's, and 12 little guys that are colored in. Step number 2, let's zoom this in a bit. Divide the tiles into groups that each contain exactly the same number of tiles. So again, how many kids can you pass out equal types of candy to? Well, you only have 3 of these guys. So immediately you're only handing out stuff to 3 kids because you're not allowed to break the candy into pieces. 4 in each group into a row, 1 row under the other. So you're actually just going to omit the tight rectangle stage, but you are going to do it in 3 rows. So I'm going to pass out one of these to each kid. That's an x squared. I have 6 x's to pass out in total, which means each kid's going to get 2. And I have 12 little guys that are colored in to pass out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Interestingly, if I change this question to minus 13 right now, I would not be able to factor this question because I would have one extra piece that I'm not allowed to break into 3 pieces to pass out. So that one wouldn't be factorable, and the answer I would write for that is prime. But this one does work out nicely. And so we've done our groups. Basically what you're going to do right now is you're going to decide what you have. You have 3 groups of an x squared plus a 2x minus a 4. And that translates into math as 3 bracket x squared plus 2x minus 4. Now, factoring using a factor tree. In some ways, it's work, but in some ways, you're probably going to enjoy it better a little bit. So, you're going to write down the first term, 10x squared, and you're going to do a factor tree for that term. It's going to be 2 and 5, and the x squared gets written as x dot x. Then we have a minus 15x in our original trinomial. We're going to drop that minus sign down. The 15 is going to become 3 and 5, and then the x is just going to drop down, and then we have a plus 20. And that 20 is going to be a 2 and a 10 and a 2 and a 5. And there's no x's here, so you're done that part. Now, grab a different color, and you're going to highlight what you see in common between all 3 terms. Again, here's a term, here's a term, and here's a term. Well, each term doesn't have a 2. Each term has a 5. This guy's got 2 x's, this guy's got 1 x, this guy has no x's, so I'm not allowed to use any x's. So again, I've highlighted them. And now what I'm going to do is I'm going to write down what I highlighted. In this case, it's just a 5. If I'd highlighted a 5 and a 6, or no, a 5 and a 3 in each case, then I would actually multiply those. But I just have a 5. So I'm going to write that down. Put a bracket. What do I have left? In my first term, I have a 2 times an x, then a minus sign, then a 3 times an x. Oops, let's drop that plus sign down there. Plus a 2 times a 2. And then your last job is just to simplify those. 5 times 2x squared minus 3x plus 4. So this is the factor of that.